All right, let's dive straight into this explainer and completely demystify how to manage your API keys without breaking a sweat. Or, more importantly, without bankrupting your bank account. Look, if you're building anything with code today, you are dealing with API keys. But how you handle those keys behind the scenes, that's exactly what separates a rock-solid project from an incredibly costly disaster.
So picture this for a second. What happens if you accidentally upload your API key to GitHub? You might think, no big deal, I'll just delete the commit really quick. But here's the terrifying reality. Within minutes, or sometimes literally seconds, automated scrapers are going to find it. They'll scoop up that key and start racking up massive usage charges on your account before you've even poured your next cup of coffee. Today, we fixed that for good. We're going to master the absolute right way to handle your environment.
When you need to supply a secret to your program, you essentially have three main options. First, you could just hard code it directly into your source code. But please don't do that because it ends up permanently in your Git history and it's basically guaranteed to leak. Second, you could pass it as a command line argument. Also pretty risky because those CLI arguments show up right there in your shell history and system process lists. Then we have the third option, the standard, universally recommended holy grail, environment variables. They live super securely in the running process's memory. They're incredibly easy to swap out when you move from local testing to production, and pretty much every deployment platform supports them out of the box without changing a single line of your code.
Okay, so if environment variables are clearly the way to go, where exactly do .env files fit into the picture? Well, think of a .env file purely as a local development convenience. Because, let's be honest, nobody wants to manually type out and export variables in their terminal every single time they spin up a new coding session. Instead, you just keep these variables neatly packed in a file and your program loads them up automatically right at startup. Now, here is the golden rule you absolutely need to remember. When you call load.env in your Python script, it sets those variables strictly for your current Python process. And that's it. It does not persist anything permanently to your operating system's overall environment. It's totally isolated. Once your script finishes running or crashes, poof, those variables vanish into thin air.
So let's make this concrete. What does it actually look like? It's really just a simple text file defining key value pairs. You can name your local variables whatever makes the most sense to you, maybe something like Google API or GROQ API, and then just set them equal to your actual secret keys. We've also got an OpenAI_API_key defined down at the bottom. This raw file just sits quietly in your project directory, acting as your own personal local vault. Once you've got that file set up, we need to build a translation layer in your Python code. The workflow is super straightforward. We import OS, we import load_env, and we run it. Python then automatically hunts down that .env file and pulls those values directly into the current process. But check out what happens next. We use os.getEnv to grab your custom name, like Google API, and we explicitly map it to os.environ under the very specific name Google_API_key.
You might be wondering, why go through the hassle of doing that remapping step? Well, certain libraries, like LangChain Google Geni, for example, are hard-coded to look for one exact variable name. If you don't pass a key directly, it strictly expects to find Google API keys sitting in the environment. But here's a pro tip. If you check the provider's SDK documentation beforehand, you can often skip remapping altogether. Remember that OpenAI API key from our file? Because the LangChain OpenAI library automatically hunts for that exact standard name, it just works seamlessly. No extra Python code required.
The danger zone, avoiding costly leaks. Because knowing how to load your keys is really only half the battle. Knowing how not to accidentally expose them to the entire internet is how you actually save your wallet. Rule number one, and honestly, this is completely non-negotiable. The single biggest mistake developers make is forgetting to add their .env file to their .gitignore. You absolutely must verify that .env is in that ignore file before you make your very first commit. Do not assume your framework or scaffolding tool did it for you. If you push that file publicly, even for 5 minutes, consider it compromised. Then we have what I like to call the just testing trap. We've all been there, right? I'll just paste my key right into the script for 2 seconds to see if this API call works. What's the worst that could happen? Honestly, everything. It is way too easy to get distracted, forget to scrub the key out, and accidentally cement it permanently into your Git history. Save yourself the headache and just use your .env file from the very first line of code, even for quick throwaway scripts. But hey, mistakes happen to the best of us. If you do accidentally commit a key, you need to know exactly how to react.
Simply deleting the file in a new commit is not going to save you. Git history never forgets. That's the whole point of version control. You have to immediately log into your provider and rotate that key, meaning revoke the old one completely and generate a brand new one. All right, let's see what's stuck. Time for a rapid-fire knowledge check. Flashcard 1. What does load.env actually persist to on your machine? Think operating system versus script.
The answer is absolutely nothing. It only sets those environment variables for the current active Python process.
Moving right along, flashcard 2. Why do we sometimes have to write that extra line of code to remap our variables?
It all comes down to internal library requirements. If an SDK is rigidly looking for one exact name and you named it something else locally, you've got to build that bridge so it doesn't throw an authentication error. Let's rewind back to the basics for flashcard 3. What are the 3 common ways to supply secrets to a program, and which one takes the crown as the best practice?
Hard coding, command line arguments, and environment variables. With environment variables being the universally recommended standard for sure.
Okay, flashcard 4. This is the big one for protecting your projects. What single habit prevents almost all API key leaks?
Verifying and adding your .env file to .gitignore before you ever type git commit for the very first time. Build that muscle memory. Last one, flashcard 5. Does OpenAI_API_key need a remapping step if you're using a standard setup like LangChain?
Nope, absolutely not. The library is smart enough to look for that exact name right out of the box, so you get to skip the busy work.
So, I'm going to leave you with a quick challenge for today. Are your current API keys actually sitting safely in your .gitignore right now? Seriously, go check your active projects, double-check those files, and make absolutely sure your secrets are locked down before the scrapers beat you to it. Thanks for hanging out with me for this explainer, and stay secure out there.